Hey ladies and gentlemen, what's up? It's Papa Bale. Checking out the progress of the toroidal. I got the third coil on. I'm shrinking the ends. I'm gonna make it so this thing can spin. We're still working on it though. We need to get a trigger coil in there. We need to get the circuitry in there. Got a plan for all that though. But see, it's all nice and tidy. We just need to get the two ends into a breadboard and a battery in there and everything. Heck yeah, check it out. So these three coils are in series. They're square shape. Well, they're circular square shape. So the bobbins are square. The first few layers are going to be square, but then it's going to circle out. And it's a funnel. So the bottom of these are smaller than the top. It's more like a megaphone. And we're going to work on stabilizing everything, and it'll wobble. I'm not worried about the wobble. I'm really not. So, I mean, there it is. That's pretty freaking awesome, I think. Just the thought that provoked this was interesting as well. So I'm gonna get a breadboard, something like this. Something like that. It's going to stick out a little bit on both sides, but it's okay if it sticks out the sides a little bit, just not on this side. So that's where the transistor is going to go. That's where the battery is going to be next to that. Well, there's only like 3 slots. It's going to end up being a 6-sided shape instead of a triangle, which is okay with me. Freaking cool, man. I can't wait to see it, if it's going to spin or not. I mean, it wants to spin, I can already see that. But it's still tethered, so I don't know like how balanced it's got to be and whatever else. And no, you can't. I mean, and in my mind, it's reminiscent of a Newman motor that's tilted on its side, but it's totally not. This is toroidal, because that's not a Newman motor coil at all. Not even a little bit. Not even reminiscent of a Newman motor coil. uh, it's 3 very small coils, and the bobbins are. See, there's 4 holes in each bobbin. You can put a 1/2 inch, 7/8 soft iron core in there. I'm sure maybe even with the cores involved, like if I put all the cores in, I don't think we're going to get enough off of that 32 gauge strand to trigger. Because even in series, there's not enough. There's like 0.2 of a volt. And the 18 gauge strand will not run by itself. It will fry the transistor instantaneously. Without resistance, of course. I'm not using resistors. I might want to try that. Use some resistor. Currently I wouldn't know where to put it. Maybe one between the trigger coil. One for the trigger coil. I'm not sure if the other needs one the way it is. Doesn't look like it does. I mean, it has this light, but I'll put the light in there in the breadboard just for, good measure. All right, so that works. They're all hooked together in series, and the only two things that are sticking out of this thing are the two ends. And we're gonna solve that, and then it'll be able to either spin or it'll need work. But I think it'll spin, but I don't think it'll stay spinning because it's very unstable. But I'm thinking of a few things that I could use to stabilize it. Like I could not have these be so far apart and push them in together. That'll stabilize it a little bit, but then it'll be hitting the sides, I'm pretty sure. So I don't know, we'll figure it out. But now that we got the toroidal ring made, we might be able to like put some cap on it on either side. Then you wouldn't be able to see the rotor spin, but I don't know if it matters. It might matter to some people. I don't know if it matters to me. But like put a cone on each side, basically, just to hold it in place. Wow, that's a sigh of like, yes. That's a yes. That's a, like, do you believe in God? Yeah. Yeah, the difference. This is a yeah moment. From, what it started out as in my head to what it is now, this is great. And who got me thinking about this was, I'm going to give a shout out. I hope he doesn't mind, Tim Tron. I saw, a toroidal rework that he was doing or that he posted. And yeah, I was off to the races. Like, I can't pass this up, especially if I can get it to counter rotate, man. That'll be sweet. That'll be dopalicious. Oh man, just really excited. You will like the reason that it's all in series and there's an external trigger is because currently if you run the 18 gauge strand alone, you will instantaneously blow your transistor just because there's no resistance on it. All I'm running here is a 1, 2, 3. You got one for the base and the trigger. You got two for the collector. One's for the light. One's for the motor. You got three for... Oh no, one's for the light. One's for the power in the collector. And then in the emitter, you got one for the motor. One for the negative end of the trigger. Or the ground for the trigger. And the other end of the light. So that's 1, 2, 3. And that's all you really need for it to work. Like, but if you want to like tweak it and get efficiency and all that stuff, you want to start headed towards something like this with resistors and diodes and little Zeners in there. A switch. You got a designated input, output, trigger coil, drive coil, transistor. This is a brilliantly designed SSG from K Energy Stores. Check it out. Among other things, I'm working on a propagator or what do we want to call it? A meg train. That's what we're going to call it. So it's an electrical generator that generates for an electrical generator that generates for an electrical generator. And we got to see exactly how much voltage we got to put in the front for it to cycle back to the front. and how much energy actually makes it back to the front. You know, it's like, and then the single one, like if you just do one section of the propagator, one car of the train, it works. It really does. It like if you circle the generator coil back into the drive coil, you generate less, but it has a like a stepper effect to it. It goes up. It doesn't just zero out to what it's going to be. It actually increases slowly. So I don't know. I think that's pretty cool. So thank you very much. Peace out. Have a wonderful day. Bye now.